Welcome everyone to our lesson 2, and in today's lesson we are going to talk about operation on sets. So we continue with our lesson on sets. Yeah. Now when we talk of operation on sets, these are just the operation that are usually there that we usually apply on sets, e.g. the union of a set, intersection of a set, and complement of a set, and many others. Yeah, I'm sure you have heard of the words complement, union of the sets, and that's what we are talking about. Operations on what on sets. Yeah. So the first operation that we are going to talk about is what is union. Yeah. So union we usually represent it like this. So the moment we see a U, that's what we mean when we say union. For example, we can say A union B. So we can say A union B. So that's the first operation on sets that's there, which is a what? Which is union of a set. Yeah. So what does this union of a set means? So whenever we have two sets, set A and set B. For example, we have set A there, and also we have set B there. So what we mean when we say A union B is, we are just trying to mean this is just the set of all elements which belong to either A or B. That's what we mean. All elements that belong either to A or B. Those are the elements that are going to be in A union B. For example, in A, we may have these elements. 1, 2, 3 in A. These are the elements that are in set A. Also, we have what? We have set B. Set B has elements A, B, what? C. Set B has A, B, C. So when you're talking about A union B, what we're just trying to say is elements that are either in A or B. So at the end, our elements that are going to be in A union B are going to be 1, 2, 3, A, B, C. So these are the elements that are going to be in A union B. I also talked about set builder notation. How are we going to write this one in set builder notation? So it's just going to be A union B, A union B is equal to X is such that X is an element, this symbol is meaning an element of A, or X is an element of B. That's A union B in set builder notation, which means we are saying this element is such that this element can be a member of A or B. Yeah, that's A union B. Now, what about in terms of a Venn diagram? Let's use a Venn diagram to represent this A union B. So in terms of a Venn diagram, we have this one. We have the universal set here. Universal set. I think I explained the universal set last time. So what about A union B? So I said the element can either in A, so we are painting A. We are painting A, or in B, so we are painting everything in B. So if you are told to write A union B in a Venn diagram, this is what we are going to do. This is A union B. So you'll find the elements of A will be in A. The elements of B they are going to be in what? In B. So that's A union B. Let's look at this example. So we have the union set to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have A, set A is equal to 1, 2, 3, 4. B is equal to 3, 4, 5, 6, 7. And C is equal to 2, 3, 8, 9. Now, let's try to find elements such as A union B, B union C, or A union C. So let's start with, let's find A union B. So what's our A union B? So we try to find the elements that are found in A and B. So we can start with A. We just list them. 1, 2, 3, 4. Yeah, 1, 2, 3, 4. We go to, since it's A union B, we go to B. it's 3. So since we already have 3, we won't write it again. 4, we already have it. We go to 5. We go to 6. We go to what? We go to 7. So this is A union B. Yeah. So that's all about A union B. These others, you can do them as an exercise. Do A union C and B union C. Yeah. Now, another example that I can give you is, we can say, let U denote the set of students at a university. This is just a set of students at a university. And also M representing for male. And F representing for female. So this is just male. This is just female. Now, if I say M union F, which is male union females, what's going to be the answer? The answer is just going to be the universal, which is the number of the set of students, all the students, because males and females, it's comprising of what? Of the students. So that's all about union of a set. Now let's go to another interesting operation, which is intersection. Intersection of a what? Of a set. Yeah, so let's go to that one. Yeah, now explaining about intersection, again we are going to use examples. We have set A and set B, and there's always a what? A U, which is what? Universal set. Now when we say A intersection B, now we represent intersection by N. When we say A intersection B, we mean elements that are found in both A and in B. Oh, that are found, they are found in A and they are also found in what? In B. We call that intersection. And how do we represent it using set build notation? We represent it using set build notation by saying X is such that X is a member of A, and also it's a what? X is a member of B. So that's how we represent it. X is the member of A and the member of what? Of B. So how do we represent it on a Venn diagram? So as we can see, there is A and B. So when you say A intersection B, how many elements that are found in both A and B? So that are found, so you find it this intersection part, the center, whereby, for example, we have 1 here. We can say it's found in B and it's also found in A. That's what we mean when we say intersection. Yeah. So that is what we call intersection, A intersection B. So we can also go back to the example that we had to now. In this case, we are going to use intersection. So when we come to this example, when we say A intersection B, which elements are found in both A and B? They are found in both ways. So when you look at 1, it's only in A. When you look at 2, it's not in B. When you look at 3, it's both in A and B. So we are going to start with what? With 3. What about 4? Even 4. So that is our A intersection B. Elements that are found in both A and what? And B. When we say, okay, let's look at B intersection C. Let's look at B intersection. So what's on B? 3. It's also there. So you start with 3. What about 4? 4 is not there. 5 is not there. Okay. So it's just 3. So there's only one element. And what did I say last time? I said that is only having one element. We call it a singleton set. Yeah. So it's going to be what? A singleton set that is only having one element, which is what? Which is 3. So that's all about the intersection of set. And how can we represent this on a Venn diagram? Yeah, so we have A and B. So let's let's put everything in the Venn diagram so that you guys can also have a skill of putting in the Venn diagram. So we start with, so whenever you are putting things in a Venn diagram, always start with what? The center, or where the elements that are found in like all the sets that are there. Yeah, so always start with that one. So for now, we have 1 is not found. Okay, we know that 3 is both found in A and B. So we start with what? We start with 3 there. What other one? 4 is also found there. So we put 4 there. Then we go to 5. 5 is just in B. Oh, sorry guys. There's also set C. So let's put set C also here. And which element is found in all the sets? It's 3. So 3 is supposed to be here. Yes. So 3 is supposed to be even in what? Even in C. What else? 4 is only in A and B. So we put 4 in A and B. We put it there. What about in B and C? What's common? 3. Only 3. We have put it already. 4, no. 5, no. 6, no. Yeah. So we got what about A and C? A and C we have 1, 2. They have 2. So we put 2 here. A and C. That is common. What about 3? It's already there. What about 4? 4 is not there. So let's go to B and C. I said it's only 3. Yeah, that's all. Now we can now go to their individual. In A, there is what? There is 1. 2 we have already put it. 3 we have already put it. 4 we have already put it. We go to B. B, there is 3. 4 we have already put it. 5, it's not there. We put 5 here. 6 and 7. What about in C? C, there is 2, 3. 2, 3 is already there. 8 and 9. So that's how we fill the Venn diagram. What about the universal set? Which element is not in all these 3? So it's only 10. So we put it outside in the what? In the universal set. So we have also covered the Venn diagram. How to fill in the what? The Venn diagram. So let's look at another one, which is complement of a set. So what do we mean when we say complement of a set? So the best example that I can give for complement of a set, we start with just the universal set. We say there's a universal set and there's also set A, which means in the Venn diagram we have something like this, which is the what? Which is the universal. Let me say the Venn diagram. Then we also have set A there. We put it like this, and we have universal there. Now, when we say complement, for example, we say A complement. What do we mean when we say A complement? We mean the elements that are not in A. So when we are going to shade A complement, we are going to shade the outside part. That's what we are going to. That's what we are going to shade. The outside part. That's what we are going to do. What? That's what we are going to do to shade. This is what? The A complement, because this is set A and the element that are not in A is what? The outside part. So that's just what we mean when we say A complement. Now, this same complement is the one that usually confuses people, especially when they phrase it in sentences. Yeah, but it's not that hard. We are going to do an example also here, but we are going to go back to the same example that we used last time. So for example, if we come here and we say, what is a complement? What is a complement? So what are the elements that are not in A? So the reference that we are going to use is the universal set. For example, 1 is there, 2 is there, 3 is there, 4 is there, 5 is not in A, so you start with 5. 6 is not in A, 7 is not in A, even 8, 9 is not in A, and 10 is not in what? Not in A. Yeah. So even when we are going to shade this, we are going to shade wherever there is these elements. For example, 5, which means this part is going to be shaded as A complement. 6 is there, also this part. 7, where is 7? Yeah, I can't. Okay, 7 is also in this part. 8 is in this part. So we are going to shade this part where there is A, but leave this part. 9, where is 9? 9 is also here. 10, which means even the outside part is going to be shaded. So the only part that is going to remain is this one, which is just wherever there is A. This is the only part that is going to be left as A complement. So be mindful of these questions when they ask you Yeah. So shade A complement, you shade wherever there's some elements that are not belonging to what, to A. Yeah. So that is about complement. So another, let's go to another one which we call relative complement of a set. So when we say relative complement or difference of sets, this is how it is. For example, we write A, we put this B. So this is just like A minus B, which means elements that are in A but are not in B. You're getting the point? Elements that are in A but they're not in B. For example, let's have a universal set here, which we have A and B. Something like this. This is B. Now, when we say elements that are in A but not in B, which means, for example, when we say A, this is A, this one is A, this one is A, but we are removing B, which means there shouldn't be any part that is containing B, which means this part is going to be left. So when we say A minus B, we are just going to shade this part. We leave B. Even this part is belonging to A, but since there is B in it, we leave it. So this is what we call A minus B. We call it relative complement. Relative complement. Yeah. So for today, let's end here and see you in the next video where we are going to talk about the laws of set algebra. For now, all you just need is what is a lot of practice. Yeah. So thank you guys for watching, and don't forget to subscribe for more